Hello everyone and welcome back to the second lesson in the Intermediate Android Development course here on AcademiCode. In this one we're going to be talking about how we can animate our views to make them more interactive and add more of a unique and custom feel to those views. So specifically today we're going to be talking about really what animation is, and more specifically what animation is in terms of a developer writing an animation into their views. Then we're going to transition into the two different kinds of animations that you can leverage in Android. We're going to talk about tween animations and keyframe animations. And then finally we're going to go through an example of actually animating an image view in Android. So to kick things off, it's important to understand what animation is. And many of you are probably thinking, well, that's obvious, that animation is something moving around. But just to be more abstract, to kind of cover everything here, let's define an animation as an experience presented by the developer to imply or demonstrate a change in an attribute of an object. And it's important to think of it empirically like this, because I know me personally, when I was just getting started writing Android applications, I always thought there was some magic involved with making animations, but it's really not that special, unfortunately. It's just the developer playing with the attributes of objects to imply some sort of motion or some change in color. A rotation would be another example of a different kind of animation that could be used. You could also move around the position, size, and color of a view on the screen. So it's really that simple, but in order to understand it more comprehensively, you need to understand the two different types of animations, in particular the animations in Android. Now on the left here, you're seeing what I consider to be the more common type of animation. This is what's known as a keyframe animation, where an image kind of cycles through a variety of keyframes which display their own unique image, which implies motion. So as you can see here, the dots are seemingly moving from left to right on the screen, when in actuality we're just rendering different keyframes. And of course you can get this to imply motion if we just had a single dot rotate or moving from the left side of the screen to the right. And if we had a lot more keyframes there, say around 25 keyframes, we could better trick the user into thinking that the ball is slowly moving from left to right on the screen, when in actuality we're just showing them a series of images with varying x coordinates on the screen. So keyframes are much more customizable. You can really do anything with keyframe animations, but they're much harder to make because you typically need one image per frame, and then you just show all your frames in a quick succession to imply some sort of motion or change in the attribute that you're desiring to animate. And on the right here you'll see what's known as tween animations, and these are much simpler to implement, at least in Android they are, but it's really just where you specify the start and the end point of an animation, and then you allow the Android operating system to interpolate for you. So you say, I want to start at X position 0, end up at X position 200, and I want to move between those points. Well, the Android operating system will simply move the view from point A to point B. How it does that depends on the interpolator that you choose to use. An interpolator really just takes two pieces of data and navigates from one to the other using a series of points that vary based on the interpolation algorithm you're using. So for example, a linear interpolator would change the value linearly until it reached the other value. A hyperbolic interpolator would be much more complex, where it would start very quickly, slow down, and then start back up. And there's a variety of different interpolators, but when it comes down to it, tween animations go between 2 points, two different sets of criteria for an attribute, and the system kind of animates it for you, which is really convenient. So we're just going to dive right into the code here and go through a real example of how we actually animate an image view. I'm going to show you the example I just showed you in the previous slide. We're going to go over keyframe animations and then tween animations, and I'll show you how the code works so you can start embedding them in your own applications. Alright, so here in Eclipse you'll see I've defined another simple application for the purposes of this demo here with just two buttons, Tween Animation and Frame Animation. This is the application we just saw on the previous slide. And what these buttons are going to do is just showcase a different kind of animation when they're clicked. So if we look at the raw XML, we'll see that we have the two buttons, Start Frame and Start Tween. And we also have two image views, Tween Animation and Frame Animation. Both of them have their visibility parameters set to gone, which is why you can't see them here, because we want to programmatically show the respective image view when we're trying to show that kind of animation, and we'll do that in the code. So when we jump over to main.java here, the associated activity, we'll see that after we've initialized our views, we have our two buttons and two image views here, we set two click listeners. The first one gets attached to frame animation, or the button start frame animation, which will start the frame animation. So here's how that's done. First of all, we ensure visibility of the frame animation view, which is not a method, it's not an Android method. I actually defined that down here. It just simply hides the other view and makes the view that you want to animate visible so that we can then see the animation happening. So first we make the frame animation image view visible, and then we set the background resource to this r.drawable.loading animation. And if I go over to the project or the package explorer here, we'll see that in drawable-hdpi we have our loading animation.xml file. If we open that up, we will see that we have an animation list XML file which contains 5 items, and these are the different frames in our application. So we have loading 1 through 5, each of which has a duration of 500 milliseconds. If we open up the images, you'll see that they vary between 1 dot, 2 dots, and then 3 dots there. So this is the loading animation XML. You have to define it like this if you're going to use a frame animation, and it's just much easier to do that way. So we'll pop back over to main.java here. We'll see that we've set the background resource of the image view frame animation, which again is this image view in main.xml. Let's maximize this. Frame animation. We set that to the loading animation XML, which is then going to simply show all the images that we've embedded in that XML document. And we have to create the frame animation drawable using this method here, simply getting the background, which we just set here, and then we want to start the animation drawable. So that's going to start iterating through those frames, and we see it in the application. So let's run it now, and you'll see in the emulator down here that when we click frame animation, it simply iterates through those images. And you can extend this to be as complex as you want. This is a very basic frame animation. This could potentially be used as a loading animation, but you can have hundreds of frames dictating a really complex animation. It's really as customizable as you want to make it, which is the power of frame animations. Of course, it's a little more complex to go ahead and define all of the frames though for a particular animation. So sometimes you want to just keep it simple. You'd want to go with a tween animation. So let's look at that in detail now. We do start tween animation.set on click listener. I know this name's a little misleading, but start tween animation is the button, the second button on the screen. And in this click listener, again, we're going to ensure the visibility of the tween animation image view, which is just going to hide the other image view first and then show this one. And then we have an animation object which varies from animation drawable, because we're not defining the drawable directly anymore. We're simply animating on a drawable which was already created. We load it using this helper method load animation. Through animation utils, we pass in the context, and then we pass in r.anim.rotate. And if we come back into the package explorer, you'll see that I've made this folder anim and I've made this file rotate. You have to make this file anim, it has to be there. And then here we have the XML that I've defined for a simple rotation animation. And this is going to go from 0 degrees to 360 degrees using the center point of the image as a pivot. And the duration is going to be 3000 milliseconds or 3 seconds. And you'll notice that I haven't specified an interpolator here. Android just goes ahead and assigns one automatically for you anyway. But you could of course modify the attribute to add your own interpolator in there if you wanted. So this is just going to simply move the animation round in a complete circle over the duration of 3 seconds. So if we come back into main.java, we will see that after we have loaded the animation, we then call start animation on the tween animation, which is the image view, and we pass in rotate. So we're essentially saying this image view, start this rotation animation, and it goes ahead and starts. So we'll go ahead and show that now. And we'll load the tween animation, and you'll see that it simply spins around once, and then it's done. So if I wanted to use frame animations for that, I'd have to define a new frame for every single part of the rotation. Tween animations make simple things like this almost trivially easy. And that's how you go about making a basic animation for a view in Android. I'm going to be very likely going into more complex ways to work with animations and different interesting ways you can animate your views in a future episode, but I want to keep it simple for now in the spirit of agility, so you can start doing things on the fly if you need to. But I encourage you to check out the source code for this video in the description below, and if you liked it, feel free to like it and subscribe. Our next lesson is going to be on managing save states, which is going to be an interesting lesson where we're going to go over how to make your application work as expected throughout the entire application lifecycle on the Android OS. But for now, thanks for watching. I'll see you in the next episode. Have a wonderful day, everyone.